Welcome to Spring LIB.
Hello everyone, in this question they have asked that explain concept of stoichiometry, limiting reagent, excess reagent, theoretical yield and percentage yield. So let us consider a reaction first here, that is carbon monoxide react with 2H2, here produce CH3OH. So here let us assume the mass of carbon monoxide is 7.45 grams and mass of hydrogen is 1.2 grams. So here we are going to find out mass of methanol produced in this reaction, that is our theoretical yield. So before first we are going to learn about stoichiometry. We are going to learn about stoichiometry, that is stoichiometry. What is stoichiometry? Stoichiometry is nothing but amount of reactants and products involved in this reaction. So here the reactants are carbon monoxide and water, carbon monoxide and hydrogen. So here 1 mole of carbon monoxide involved and 2 moles of H2 involved and 1 mole of methanol is going to produce. So this is our stoichiometry. What is stoichiometry? Stoichiometry is nothing but amount of reactants and products involved in reaction. What is stoichiometry? Stoichiometry indicate that amount of reactants and products involved in this reaction. So in this reaction, how many reactants are involved? Here 2 plus 1, 3 reactants involved. So how many products involved? Here 1 product involved. So this indicates stoichiometry of the reaction. After that we are going to learn limiting reagent, limiting LR, that is limiting reactant. So for that first we are going to find out number of moles of carbon monoxide and number of moles of hydrogen. So N of carbon monoxide is equal to, as we know that number of moles is equal to mass of the compound divided by molar mass of the compound. So number of moles of carbon monoxide is equal to mass of carbon monoxide, that is 7.45 grams, upon molar mass of carbon monoxide is 28 gram per mole. Here we will get number of moles of carbon monoxide, that is equal to here 0.266 moles. Similarly we are going to find out number of moles of hydrogen, that is N of hydrogen. So mass of hydrogen is 1.2 grams and molar mass of hydrogen is 2 gram per mole. So here we will get number of moles of hydrogen is 0.6 moles. Here it's clearly indicates that number of moles of carbon monoxide is less than number of moles of hydrogen. Therefore here carbon monoxide acts as limiting reagent and hydrogen acts as excess reagent. So what is limiting reagent? That is limiting reagent is nothing but reagent. Limiting reagent is a reagent. It is a reagent which is completely consumed in reaction, Here 0.266 moles of carbon monoxide is completely reacted with 0.266 moles of hydrogen out of 0.6 moles. So here the moles of carbon monoxide is completely involved in this reaction, but moles of hydrogen is not completely involved in this reaction. Out of 0.6 moles, only 0.266 moles are only involved in this reaction. So here H2 act as a excess reagent. So here what is excess reagent? It is a reagent which is not completely consumed in reaction. Here we have N of H2, how much it is? That is 0.6 moles minus how many moles is going to be reacted? Only 0.266 moles only reacted with number of moles of carbon monoxide. So here we will get number of moles of hydrogen that is remains present in this reaction is how much it is? That is 0.334 only. Still 0.33 moles of H2 is present in this reaction, that is why it acts as a excess reagent. So after that we are going to study about theoretical yield. Theoretical yield, that is Ty indicates theoretical yield here. So here now we are going to find out, here the product is methanol, so here we are going to find out theoretical yield of methanol. So here that one is depends upon the limiting reagent. So according to our balanced chemical reaction, 1 mole of carbon monoxide is produced 1 mole of methanol. So here we have 0.266 moles of monoxide, carbon monoxide is always produce 0.266 moles of methanol. So here from this we can say that N of methanol is also 0.266 moles. After that we are going to find out mass of methanol, that is M of CH3OH is equal to N into M. N is equal to number of moles, that is 0.266 into molar mass of methanol is 32 gram per mole. Here we will get mass of methanol produced in this reaction is equal to here, which is equal to 8.1 gram. So this is our theoretical yield. After that we are going to find out percentage yield. Which is equal to practical yield upon theoretical yield. Let us assume practical yield is 7 gram upon theoretical yield. Here we got 8.1 gram into 100. So here we will get percentage yield, which is about 86.41%. So here actually we have to produce 8.1 grams, but here in practical we produce 7 grams. So that is why the percentage yield is 86.41 grams. So this is our percentage yield. So this is our theoretical yield. So here 7.45 grams of carbon monoxide react with 1.2 grams of hydrogen, it always produce 8.1 grams of methanol. This is our theoretical yield. Hope you found the video useful to you. Thank you.